Okay, so in this video, we're going to learn about distribution of shapes. So if you will label your notes and pause the video and actually draw all three of these distributions with their labels as you see them. Okay, one of the things that you do not have to draw or you can cross out is this part about mode. Mode is important, but honestly, I've never seen this in statistical distributions anywhere else. We're mostly going to focus on the mean and the median. So some things that I want to point out to you. The first one over here on the left is called left skewed. That is because the tail is on the left. So you need to label for yourself. This is because the tail is over here on the left. That's really hard for me to write, so I'm not going to do that. Also, you should note that the mean is to the left side. The mean is to the left of the median. Similarly, on right skewed, the tail is on the right, and the mean is on the right side of the graph. And of course, in a normal distribution, they are symmetric, and mean and median are both going to be right here in the middle of the distribution. So if we look at a few examples, we're just going to talk about how to interpret distributions and what they tell us. So we see two distributions here. This is talking about the weights of dogs in different categories in a dog show. So in the first one, notice the mean and the median are both 45. So this is symmetrically distributed. We have kind of the same amount to the left as we do to the right, and they seem to be sitting the same way. In this second group, this is a little different. I noticed that the mean is higher. That means that my tail is on this upper end. So this would be an example of a right skewed graph. What that means is that while most of the dogs are here on the lower end, we do have quite a few that kind of spread out here up on the right side. Then it says, suppose that we have a third category of dogs. So we've got the mean, the median, and the mean. So in this example, when we talk about the median and the median is where the most will be. The mean is where the tail is. So we get a graph that looks like this that is also going to be right skewed. All right, now we've got bagels. We're going to compare distributions of bagels. So in this set, we see that the mean is less than the median. So most of my bagels are in this set, but I have some on the low end. This is an example of left skewed. Okay. Again, the mean is less than, so it's over here to the left. The question is, would this warrant getting a new set of bagels? Because they're saying their bagels are 90 grams, and this is what they have shown. The control manager says, well, we only tested 30 bagels, so let's draw some more just to see if this same trend holds, if we need to adjust something about our manufacturing process, or if maybe something is wrong with our data. So they do another set. The question is, how do these compare? So first, it looks like, well, this set shows the other side. I noticed that these don't line up exactly. So 85, like this median is still at 90, where this median was at 90. So if we overlap them, we get this graph that looks like this, where they're equal in the middle. And now this is a very symmetric representation. I have some that are low to the left and some that are low to the right. And together we get a symmetric representation, which should mean that actually the bagel shop process is pretty reliable because they have a symmetric distribution. All right, and our last example would be using data to make a decision. So this person is trying to decide which job she should go for. I see a relatively symmetric representation here in the first one. The second one is right skewed. Most of the salaries are lower, with a few salaries up on the right side. This last one is going to be left skewed. I see most of the salaries are higher, and then very few salaries on the left. On the left side. Let's label these symmetric. This one is right skewed. This one is left skewed. So then the question is, well, what if she has this fourth offer? So if we have this fourth offer, again, median, this is where most of our data will be. And then mean is where the tail is going to be. So we end up with a curve that looks like this. So then the question would be, where is it should she decide to take a job offer? And to me, it looks like school 301 is probably going to be her best option. All of these data points are up here towards the top. 4 looks very similar to 1. It's not that all of them are up here, though. She does have the option or the opportunity for her to have a low salary. So it looks like while the first one's more reliable, the second one's going to have higher options. The District 2 and District 4, she's probably less likely to have a high salary in those places.